Welcome to Maths Group. So today in this video we will learn about fundamental theorem of arithmetic, right? And before we learn this, first we will learn about prime numbers, what are prime numbers, what are composite numbers, and using this fundamental theorem of arithmetics, we will see how to have the prime factors of any composite number, okay? And then at the end we will learn how to calculate LCM and HCF using the prime factor, okay? So let's begin. So I have covered this in the previous video also, but just to summarize, the prime numbers are those numbers which are divisible by themselves or 1, right? For example, 2, 3, 5, 7, all these are prime number, right? Like 11, 13, 17. You will not find any factor of these prime numbers except 1 or the number itself. Whereas the composite numbers are those numbers which have at least 2 positive divisor, right? For example, if I take the example of 4, right? So it has the factor 1, 2, 4, right? 6, if you can see that 1, 3, 6, right? So here, except the number itself, you will have one more factor, right? At least minimum. So those numbers we can call it as composite numbers, right? So prime numbers are numbers which is divisible only by the number and the 1, and composite numbers are those numbers which have more than 2 factors, right? Like 4, 6, and any numbers you can say that, right? So the fundamental theorem of arithmetic says that every integer which is greater than 1 can be expressed as a unique product of prime number, okay? So any numbers greater than 1, right? So even if the number is a prime also, for example 5, so what we can do that we can write 1 into 5, right? These are the prime numbers. So sorry, 5, right? So these are the prime numbers, right? Similarly, if it's not a prime number, right, 10, so we can express it as into 2 into 5, right? 2 and 5 are prime number, right? Similarly 15, right? If I can say that 3 into 5, right? 30, 2 into 3 into 5. So the fundamental theorem of algorithm says that every integer, whether it's a prime number or a composite numbers, can be expressed, which is of course greater than 1, can be expressed as a unique product of prime number. So we can say that these are the factors of 60, right? Okay. So any numbers we can find out factors, right? And we can generate the prime factor tree also. So here, like you can see the example of 600, right? So if I divide 600 by 2, 300 will remain. Then I again divide 2 by 300 by 2, okay? Then 150 will be there. If I divide 150 by 2, it will be 75, okay? Then I cannot divide 75 by 2, so I will pick the next larger prime number, which is 3. So 3 can divide 75, so it's 25 into 3, okay, 25, and then 25 can be divided into 5 into 5, right? So if you can see, you have 1, 2, 3, 3 times 2, right? Then 1 times 3, and then 2 times 5. So it can be expressed, the prime factor can be expressed like this, right? 2 to the power of 3, right? Into 3 into 5 to the power of 2. So we can call it as prime factor. So any numbers can be expressed as the factors in the prime number format, right? Let's take one more example of 840, right? So like we did it in the previous video, we will start with the first prime number, which is 2, right? We will start with 2. First we will divide it by 2, 840. Then 430 will remain. We will divide again with it can be divided by 2. So we will divide it. Similarly, we will do it here also. Now 105 will remain. It cannot be divided by 2, right? So we will pick 3. So we divide it by 3. 35 will remain, and then 35 is 5 into 7. So if you can see that we have 1, 2, 3 2's, 1 3's, 1 5, and 7, right? So I can write it as this: 2 to the power 3 into 5 into 7. All these are prime numbers, right? Now these prime numbers can be used to find LCM and HCF, which we will see in the next slides, okay? So LCM is your least common multiplier, right? Least common multiplier. It means that the number, you have to find a number which can be divided by both the numbers, right? For which we have to find the HCF. And HCF is the highest common factor, which says that the highest number which can be the factor of both the number, right? So in this example, we have taken 18 and 12, right? So if we find the factors, it would be 2 into 3 to the power 2, and 12 would be 2 to the power 2 into 3, right? So HCF, we have to find the highest common factor, right? So what we will do, here there are only two factors, 2 and 3. So we will pick the minimum of 2 to find the highest common factor. 1, here it's 1, right? 1 and 2, and in the third 3, minimum of 2 and 1, right? So to find that HCF, we will find the minimum factor, right? So it's 2 into 3, so 6, right? So let's verify. So 6 can divide 12, 12 can be divided by 6, right? 6 to the 12, and similarly for 6 into 3 is 18. So 6 would be the highest common factor for 18 and 12, right? Similarly for the LCM, right? So here we have to find a number which can be divided by both these numbers, right? So here we will pick the maximum. Okay, so 2, 1, 2, the maximum would be 2 to the 2, right? And similarly for here, it's 2, 1, so maximum would be 2, right? So 36 would be the LCM of this number, right? So if you can verify 36, you can 12 can divide 36, and 18 can also divide 36, right? It's 3 and it's 2. Let's do it for one more number, 64 and 80, right? So 64, you can write it as 2, if you can divide it 2 into 2 into 2 into till 6 times, right? 2 to the power 6, right? And 80 would be 2 to the power 4 into 5 to the power 1, right? So here, if I have to find the HCF, so what I will do 2 minimum 6 4. So I will pick 2 to the power 4, right? And 5 0 1. So here we don't have 5, right? So we will not pick that 5 to the power 0. We will pick it, right? So it will come up to 16, right? 16 is the highest common factor for 64 and 80, right? Similarly, LCM, we will have to find the max. So between 6 and 4, we will pick 2 to the power 6, right? And here 5 0, so we will pick 5, right? 64 into 5, 320 would be the LCM for 64 and 80. Okay, so using this prime factor and using the algorithm, we can using prime factor, we can find the LCM and HCF of any numbers. Okay, I hope you have found this video interesting. Please do like this video and subscribe to our channel. Thank you.